It's definitely a pleasure to meet you, and it's definitely a pleasure to welcome our audience to this conference. Uh, a few words about myself. I work at Microsoft as Cloud Developer Advocate. So what I do is I talk about our products to developers, to students, to universities. I work a lot with universities in different countries. And I also pass back the feedback to our product teams. So if you are not happy about something, about some Microsoft products for developers, you know whom to reach. And today I will talk about Azure Machine Learning. Um, and in the presentation that I will be showing today, there will be some links. And if you want to follow them, and if you want to get the presentation after the talk, here is one link that you need to know here on the slide. So just make note of it, and then you can relax and enjoy the talk. A little bit about my background. I work in Microsoft for 15 years. I used to be technical evangelist with different technologies like Windows Phone, but originally my background is artificial intelligence. So I'm really happy to come back to this area. I was software developer in Microsoft for a couple of years, working with large European companies and helping them introduce artificial intelligence in their business processes. So I know the pain of training the models, of working with data. And Microsoft has the solution to solve that, which is Azure Machine Learning, which I will be talking about today. But the problem is that this product is kind of complex and very broad. So it's not always that people use that. It requires a little bit of learning curve. And I hope with this talk to break the ice and to get you interested in Azure Machine Learning and to get you started learning it. One more thing that I do as a hobby, I try to use artificial intelligence to create some kind of art like this. This is two of the things that, two of the techniques that I come up with. If you are interested to learn more, you can always jump to my website and have a look. And maybe I will have time to talk about training generative adversarial models on Azure Machine Learning later today. So if we talk about the cloud is definitely a good place to do artificial intelligence, because to train machine learning models, you need a lot of data and you need a lot of computing power. And both of those things are available in the cloud. So at the base, at the baseline in the cloud, there is compute and storage. On top of that, there are many services. There are some like the simplest thing would be probably a virtual machine, and that is how many people actually use cloud. They just think that, okay, I need to train a model, I need to grab the powerful virtual machine with GPU and use it as the computer to train the model. That is not the best way, but you can definitely do that. However, there are some more convenient tools for doing big data and artificial intelligence. In particular, Azure Machine Learning that I will be talking about is a tool that is supposed to be one-stop place for whenever you want to train your machine learning models. And another similar platform level technology is Azure Databricks, which is essentially a managed Apache Spark in the cloud. And by managed, I mean that it's really easy to spin up the cluster, to get rid of it. Essentially, you are getting a notebook, Jupyter notebook, where you can type Spark code and execute it, and then easily add and remove compute. So I will not be talking about big data today, but if you are interested in that area, Azure Databricks is definitely a place to look at. And also there are a lot of other things, like because cloud makes it very simple to create complex software systems, there are some building blocks which contain pre-trained AI models. Again, I will not be talking about those today, but those are cognitive services, and they can solve typical tasks connected with computer vision, understanding speech, processing language, and so on. And those services, they are good because in many business scenarios, we are dealing with really typical tasks like recognizing certain objects on video or in the image, those kind of things. And to train those models, you don't always have to start from scratch. You can use some of the pre-trained functionality and use those building blocks to actually put and construct your system together from existing parts. But today, again, we are talking about Azure Machine Learning. Let me show you, because I started talking about virtual machines, how easy it is to create and use the virtual machine in the cloud. This is the short pre-recorded demonstration. Essentially, we log into the portal. We say, I want data science virtual machine. And the good thing about data science virtual machine is that it contains all the tools for data scientists pre-configured. So what we need to do, we just need to specify like the name of the machine, then the type of the machine. If you want GPU, it's NC series of machines. It would be like this one is the simplest GPU machine. Then I provide password and I say I want to create this resource. And in a few minutes, I'm getting this machine provisioned. What I can do, I can configure DNS name so that it's easily reachable from the internet, so that I don't have to remember the IP address. And that's essentially it. I can immediately start using the machine through SSH if I want to do some kind of command line training. Or data scientists, they most often used Jupyter notebooks. So if I want to use Jupyter notebooks, it's already pre-configured in this virtual machine. So I can essentially jump in, type in the username and password, and I'm off to a good start. I have the GPU machine with the Jupyter notebook available within only a few minutes. And by the way, it also contains a lot of demo notebooks. So if you want to start learning, it's a good place to start, a lot of examples and so on. So that's virtual machines, but not that is not the best way to work. Why is that? Well, normally when I personally worked as a developer, we started with virtual machines. But soon and with virtual machines, you can use Jupyter, you can use SSH, you can use even Visual Studio Code Remote, which is really convenient way because you can connect your Visual Studio Code environment directly to the virtual machine and use the file system, you use everything within that virtual machine while working on your computer without needing to explicitly connect like remote desktop or something like that. But the problems are cost optimization and resource management, because normally a data scientist spends about 80% of time working with data, not training the model, but actually transforming the data and getting it prepared for deep learning. And for that, you don't really need a GPU. For that, you can have a CPU machine. Because GPU machine is more expensive, and actually it's a good hint whenever you set up the GPU virtual machine. Azure supports a function called automatic shutdown. It's always wise to set automatic shutdown at midnight so that you don't leave it open for a few days. I mean, that happened to me a couple of times, and that's something you don't want to happen in your production environment when you are paying for the cloud. So as I mentioned, the data preparation is about like 80%. Some say 80%, some say 70% of the time. And then for training, you need a GPU, or even better, you might want to train big models on the cluster. And then you have deployment. Deployment is considered to be relatively easy, but still, if you want to deploy a scalable model that will handle high load, you would need to think about doing that on a cluster, on Kubernetes, or a scalable virtual machine set or something like that. So how can we take this into account? And by the way, in addition to this, what we want to do also when training the models, we want to do hyperparameter optimization, and that requires running a lot of experiments. And if you do that manually, it's not really pleasant thing to do, because you run experiment, you need to record the accuracy, and you need to save the model somewhere not to confuse anything, and then repeat that several times. Ideally, there should be some tooling to help with that. So normally, if you want to minimize costs while using virtual machines, what you end up having is having two virtual machines, one CPU virtual machine and one GPU virtual machine, so that you can use a CPU virtual machine for data preparation and you can use GPU for training. But the problem immediately arises, like, how would you share data between those? Because like in a virtual machine, if you just train in a simple way. You just download data to the disk and then you train it in a normal way. But if you want to share data between two machines, you have several options. And actually, when I was thinking about that, I wrote a blog post about those different options. How can you share the data between two machines, starting from copying over like before training each time, and ending with using so-called fuse driver, which allows you to mount cloud blob storage as a disk to the virtual machine. Each method has its own advantages and disadvantages. In my blog post, I compare the access time, how long does it take to get the data out of the shared storage, and so on. But you have to do all that manually, which is not really nice. Even if you solve that, if you have the shared storage, you start having problems when you work in a group. If you have many people working on the same problem, what you want to do, you want to share data with them, you want to share experiments, results, and so on. You want to have essentially a one workflow for the team. Another thing that you might need is to have distributed training on the cluster of machines. In this case, you need to manually set up this cluster to make sure they have the same environment, distribute the training scripts on all of them, and that is again a manual process. So if you want to train properly, then you would end up having this kind of complex setup. You have data and models sitting somewhere in the cloud. Then you have the data prep virtual machines, maybe several of them for different group members. And then you have the cluster for training, you have cluster for deployment, and you have the registry for your models. And some laboratories, I know, they create this infrastructure themselves. They design some kind of training queue where people can submit their scripts and those will run on the cluster, register in the registry, and do those kind of things. But that requires some work, some custom tooling. Azure Machine Learning is actually can actually do that for you. That is exactly why Azure Machine Learning is useful, because Microsoft, we faced those problems ourselves. Azure Machine Learning came up as the internal product, which was later then improved and released to the public. It is something we used for training models internally, and we were facing those problems, large-scale problems. So the problem with learning Azure Machine Learning is that there is no one recommended way to use it. It's a collection of tools. So essentially, when you start using Azure Machine Learning, you have so-called workspace. Workspace is something that unifies like different things, starting with data sets and data stores. Like once you have the data, you can upload it to the data store inside the workspace, and all other components will have easy access to it. And dataset is something which is defined on top of data store, providing some structure. So dataset, you can think about it as a table essentially, with some additional metadata, and data store is raw storage. Then you have compute. So within the workspace, you can define specific Azure ML compute instances, which are essentially virtual machines, but specific virtual machines which can be used. I will show you in a nice way together with datasets, and those compute you can access with Jupyter notebooks. Then you have compute clusters. You can define a compute cluster, and you can schedule experiments to run on that cluster. So scheduling experiments means that you define some kind of environment where the script will run, and you submit it, and then Azure ML takes care about scheduling, about deploying environment to the cluster, about copying back the results, about recording the results in the registry. So all that is taken care of. And then there are also model registry and deployment cluster, so you can deploy your model right within Azure ML as well. So all that is kind of relatively advanced functionality, but there are also tools, low-code and no-code tools. As previous speaker said, low-code and no-code is the future of the cloud. We also want to provide some tools for people without deep machine learning background to be able to use AI and ML. So there are different styles. As I said, there are a lot of tools, and you can use them in a very different way. You can use Azure ML just to run Jupyter Notebook, which will be easily switchable between GPU and non-GPU machine without the need to copy the data over. That would be transparent. You can then add functionality to track the results of your experiments and store them in the catalog. Even better, you can schedule your experiments to run on the cluster, because if the experiment is big, you don't want to keep the machine on for the long time. You can just say, I want to schedule this experiment. It will run, and whenever it finishes, the cluster will scale back to 0. You wouldn't pay for it. You can use Azure ML to do hyperparameter optimization, because if you can schedule one experiment, you can schedule many experiments and select best parameters. You can do parallel training, model deployment. You can set up pipelines using MLOps. So, for example, you can say that automatically I want to try to detect the drift of the model, like how much the data parameters changed, detect when you need to retrain it, and trigger the retraining process automatically. So different ways, and that makes it a little bit confusing. So that's why there is no one tutorial. This is the best way to use Azure Machine Learning. There is no such tutorial. There are many different ways, and people, for example, without a lot of machine learning experience, they will go and use no-code tools. And no-code tools, they are very different from advanced parallel training on the cluster, which is like normal. The good way to think about all those tools when they come together is when you think about what you do when you want to try and deploy a machine learning model in your business. To start with, you might want to do a proof of concept, like to see if the model can be trained at all, if you can get some kind of accuracy from the data that you have. So you can do that. You can start collecting data into Azure ML datasets, and then you can use no-code and low-code tools to build the first iteration of your model. And that can be done even without bringing in expensive data scientists. That can be done by like a person with relatively, like, with some computing experience, but without a lot of machine learning experience. You can easily get the proof of concept working. Then when you bring in data scientists, they like to start using notebooks and figuring out like how the data looks, like how we can um, define different model architectures. And you will use Jupyter notebooks to train the first version of your model. Then when you want to optimize hyperparameters, you can easily export the notebook into the Python script, and you can schedule this Python script to run on cluster with different hyperparameters to find the best hyperparameters. And finally, when you are ready to host your model, you use hosting from Azure ML to host the model in the production cluster. That is the typical workflow that shows why all those tools are unified together under one brand, because you can use all of them in a typical workflow for deploying a model in production. So if you want to learn more about it, actually this talk is I put it together from the materials of the workshop. The workshop is longer than 45 minutes. It's essentially a several hours workshop when you can try everything by hand. And if you want to do it, you can do it yourself by going to this GitHub repository. It contains instructions like what you can do and how you can do it, and some sample code. So that is a good way to start learning Azure ML. And another good way is to read a series of blog posts, which I will share at the end of the talk. So if you don't have access to Microsoft Azure, you know that everybody has an access to Azure free trial, which gives you $200 for a month to experiment with. And if you're a student, you have some other options like to experiment with the cloud, like Azure for Students, and that can be used to learn more and experiment more. So let's start. I will show you some of the functionality. The first thing, once you want to start using Azure ML, you need to create this Azure ML workspace. And this can be done by from Azure portal. So you can go to portal.azure.com, and then you say, I want to create a resource. I want to create Azure Machine Learning Workspace. Or you can do it using the command line. So with Azure, every operation can be done either through the portal or through the command line through Azure CLI. So Azure CLI allows you to do it in a repeatable way. So here, first of all, if you want to use ML in Azure CLI, you add this Azure Machine Learning extension, and then you create the group, then you create the workspace, and also you create here the compute cluster, which we will need later. You can also do that manually through the portal. And let me show you how it looks from inside Azure. So when you create the workspace in Azure, it would essentially look like this. This is Azure portal. Let me make it a little bit larger for visibility. Okay. So you say create, you select Azure Machine Learning Workspace, and you end up with a resource like this. And here there is one important button which says Launch Studio, and it will launch a separate machine learning portal, which it looks similar to the Azure portal, of course, but here it contains everything related to the workspace. So here you can see there are notebooks, there are things like automated ML, designer, datasets, experiments, and so on. Everything that I mentioned on my slides. And let me start by showing you how to use low-code and no-code tools. And to do that, we will use a data set of passengers of Titanic. You all presumably know the story of Titanic, the ship that sank. And there is a data set of passengers, which I have taken in the CSV form. You can find it easily on the internet. And I uploaded it to these data sets, to the data sets. So you can say, I want to create a data set. I want to create it from local file, and you upload it here. And the data set looks like this. It's a table. You can explore it right here in the portal. You see it has the name of the passenger, the flag, whether the passenger survived or not, the class, first, second, or third class, gender, age, and then CBSP is whether the passenger had siblings or spouses on board, and whether the passenger had parents or children on board. And then there are some other information like ticket, fare, cabin, and so on, and destination. So presumably you want to be able to predict the probability of your survival on Titanic. How can you do that? So the first tool that you can use is automatic ML. So the way automatic ML works is very simple. You say, I want to run an experiment. It tells you to select the data set. I want to take this Titanic data set. Then I want to create a new experiment. Then you specify the target column. So I want to predict the survived column, whether the person survived or not. Then I select the compute cluster. So AZML, I have two clusters, with one with GPU, one with CPU. So in this case, I want CPU one. Then I select the problem. So in my case, it's classification problem, survived or not. But I can also do regression problems and time series forecasting. And then I can do some additional configurations. Like I can say which columns I want to include, which I don't want to include. So for example, I don't want to include name because name does not have a predictive power. Well, it has the predictive power, but the model can just memorize the names, but that is not my goal. My goal is to be able to actually figure out what makes you what makes it easier to survive on Titanic. Definitely you need gender, you need age, you need maybe you need siblings and parents, and probably you don't need tickets and so on. So the good thing is that even if you don't know like which fields you need, which fields you don't need, Azure ML will try to help you, and it will automatically ignore the fields which do not have a lot of predictive power. So for example, if it sees that tickets are all different for all passengers, it will just remove this field and not use it for predictions. So it is pretty clever technology. Um, and then you just say next, and that's it. It will schedule the experiment, and the experiment will run for some time, trying different algorithms to solve this problem. So let me show you at the end. You will get this experiment, and this experiment, you see it run for 34 minutes. And if you go inside the experiment, you see models. It shows you all combination of models that it tried and the accuracy it achieved. So there are a lot of different attempts you can see, and finally you can get the best model on the top here. So the best model is voting ensemble, which is logical, right? It tries different models and combines the results. The accuracy is 80%, which is close to what you can get with Titanic dataset. And you can also say, like for the top model, you can view explanation. And explanation is a nice feature of Azure ML because it allows you to try to understand how the model works, which is something really difficult to do with deep learning, especially. But there are different ways like this explanation works. It can, if the model is simple, like regression, it can do so-called glass box explanation when it looks inside the model. It can do black box when it tries varying different parameters and seeing how the model behaves. So in my case, I can easily see what are the most important features, which features affect the result. And you can see that gender is the most important feature, and second one is the class of the passenger, then age, and then parents and children on board, which is like the logical result. So with AutoML, you kind of train your instead of being clever and trying to think which model will work best, you say, I want to try different combinations of models. And then, because the cloud has a computing power, you can try to do that. That works with simple models, like with tabular data, that works reasonably well. Of course, with complex deep learning models, it will not work, but this is one of the good approaches that you can use. Another approach is called Designer. So Designer allows you to define experiments as a diagram. So here I will start with showing you this Titanic experiment already created. So what it does, it essentially defines the pipeline. So each block in this composition is a simple container which contains like a step with transforming the data. So we can start here with the data set. So the beginning here is the data set. I can easily drag and drop it from the left, from the palette. So for example, this is another data set, and I can drop it here if I want to use it. And then I can, from this data set, I can make it input to any other parts of the model. So I will delete it. So starting with the data set, the first thing we do, we select only columns that we need. So here I select class, the survival flag, gender, age, and siblings and parents and children. And I ignore all the rest. Then I split data into train and test data set. On the train data set, I train the model, and I specify the class of model here. So I want to train two-class logistic regression, which is the simplest possible model. When I train the model, at the end, I have the trained model. I can score it. So I score it on the test data. And finally, I use evaluate. And evaluate means that I want to calculate the metrics, essentially, of the scoring. So that is the experiment. I can essentially submit it. And I select the compute and I submit it. It will take some time now to run because my cluster is now like scaled down to 0 nodes. So what will start happening now is that this pipeline would be scheduled to run on the cluster, and it will take some time to run. While it's running, I will continue talking, and then we can have a look at the result at the end. So you see, this designer is a good way if you know what you are doing. Like if you want to combine, if you want to compare several models, and you know that model architectures, you can in designer you can describe the experiment in the visual way. It's also a nice tool for professionals if you want to combine different steps in the pipeline. So suppose you have your own script that trains the model, or your own script that applies certain deep learning models to the data. You can define them as the building block inside the designer, and then you can define more complex pipelines on top of that. So it's kind of combined tool for both beginners and more professional data scientists. Uh, so next thing, so no code tools are good for no code approach. If you want to bring data scientists and have them use Azure Machine Learning, the first thing they would ask, can I use Jupyter notebooks? And with Jupyter notebooks, definitely we can do that. There is a section called notebooks. And the advantage of notebooks in Azure ML is that notebooks, they are decoupled from compute. So let me show you an example of a notebook that was used to train entity extraction model on medical data. So this notebook takes the marked data with medical entities and tries to train the transformer model to extract entities from text. So it's normal notebook, but this notebook is decoupled from data. So you can see right now, you can view it here, but you cannot execute anything because it's not connected to compute. Here you can say I want to connect it to any of the available computing resources. So I have here the normal virtual machine, the GPU virtual machine, and also a temporary virtual machine for some reason, which I probably don't need, but I have it here. And then you can like start the compute if it's not started. And once you start it, you can start executing the cells. But this compute has access to all the data, all the directory with all the notebooks that you have here. And the way it works is that it doesn't copy the data over, it just mounts this data directory directly to the compute. And that is really good approach because you don't have to, you keep data separate, and this data can be used by different compute options. Even better, this notebook directory is kind of private to you as an individual. But if you want some data shared between different people in your team, you would use data sets. You have already seen like Titanic data set. But what I can do here with data sets, once I upload the data set, let me go back to this Titanic example. Here is my data set. But if you want to consume this data set, you have the code here, which can be used to get access to the dataset easily with just a few lines of code. So you see this ends with dataset to pandas data frame. So you upload the data, you copy the code from here, you paste it in the notebook, and you have the access to the data, which is available to all members of your team, all members who have access to this workspace. Definitely a very convenient way to store the data. Now let's go to more serious things, because just running notebooks doesn't look like a huge improvement in your process. How can you do something more interesting? And to do something more interesting, we will learn how to schedule experiments on the cluster and how to monitor and track those experiments. And you can do that in several ways. You can do this through Azure Portal. You can say, I want to run this Python script as an experiment, but that is not preferred way because it's time consuming. You need to click, click, click. And then if you want to run the experiment again, you need to click, click, click again. You can do that via Azure CLI. So you can say, I want to submit the experiment, and you can type in the command. You can do that from Python SDK. So you can write Python code, which will take another Python code and schedule it to run on the cluster. Or you can do that from Visual Studio Code. And Visual Studio Code is probably the easiest way to do that. So you need Visual Studio Code and you need an extension for Visual Studio Code. So let me show you how that actually looks in real life. I'm showing you the code from the GitHub tutorial that I have shared previously. So you can always come back to that and have a look at it yourself. So in this tutorial, there is a simple training script. And this training script, so let's start with train local. It's the very simple scikit-learn script to recognize handwritten digits from the MNIST dataset. So MNIST dataset is a very famous dataset with handwritten digits, and the main thing about it is that nothing can go wrong. It's like whichever model you train, it will give you relatively good accuracy. So I take the simplest scikit-learn regression model, I train it here, and I can run the script locally, and it will give me some kind of accuracy. Now, what if I want to run the script in Azure Machine Learning? I can enhance it a little bit, and I can add a couple of lines. So first line is to import some Azure ML objects, run, which is the reference to the context where the script will run. And at the end, what I do with this run, I say run.log accuracy. So I log the result of the experiment. Now, and the rest of the code is the same. So what I can do here, I want to schedule it to run on the cluster. The Azure Machine Learning extension, once you install it, Azure, it looks like this. Here is machine learning. I have my subscription here. For some reason, okay, I will reload the window. Something went a little bit wrong with VS Code. That happens sometimes when you use the pre-release version. So this Azure Machine Learning extension, it gives you access to all the objects which we have seen in the cloud, like cluster and experiments and so on. And once you want to run this as an experiment, I have to wait until this thing loads, unfortunately.
Dmitry, and I have a small kindly reminder that we still have 10 minutes till the end of the session. So just
We
keep it
should be
in mind.
switching towards the answers, right? Towards the
Yeah,
questions.
yeah. So
Good,
just
good, good.
continue and please finish, but
Okay,
we still
okay,
hope to have questions. Thank you.
okay. So let me show you the results. I'll show you how to schedule the experiment using the presentation. So we enhance our scripts a little bit by providing this logging code, and then what I need to do, I normally describe the experiment using some configuration file, some YAML configuration file. In Visual Studio Code, the nice thing is that you can generate this file almost automatically. You just take the script and you say, I want to run it on the cluster. It will generate this file for you, and then you just specify some details. You can say, okay, for the environment, I want to use TensorFlow. For the compute target for the cluster, I want to use this cluster, and I want to mount this data set. So all that Visual Studio Code helps you to populate those fields because they are auto-completed and so on. And once you do that, you just submit the experiment with one button in Visual Studio Code. What happens when the experiment runs in Visual Studio Code? The current folder and the current code from your computer is transmitted to Azure ML Workspace. Then Azure ML Workspace creates the Docker image automatically with your environment. It deploys it on the cluster. It mounts the data stores, and then it runs the scripts, and it streams back the logs from the script to your machine. That is really good. Just you can essentially schedule it on the cluster and see how your script works. And then it also takes the output directory and all the logging results and stores them as part of the experiment. So you can always then go back to Azure ML. You can go to the section called experiments, And here you would have, like, I will open this simplest Keras experiment. You would have different runs. For each run, you would have its own accuracy, so you can compare them right here on the diagram. And for each experiment, if you go inside, you will be able to exactly see like what the script has printed, what was the output directory, what is the model, which, because the model, if you store it in the right place, it's automatically kept together with the experiment, and so on. So if you the scheduling experiments gives you a lot of advantages, because once you learn how to do that, and I'm showing you that you can do that via command line, and you can do that also from Visual Studio Code. Once you know how to do that, you can easily schedule a lot of experiments with different parameters, and select the best parameters for your model. And this can be even done automatically. So you can describe this so-called parallel sweep job. You specify what values of parameters you want to test, and it automatically schedules the bunch of experiments for you. So hyperparameter optimization becomes an easy thing. Well, not completely easy, but you need to be accurate enough, like, to specify everything in this description file. But then you don't have to manually keep track of all experiments. You just leave them to run overnight, and you get the results. Okay, I will be stopping here. A few other things that you can read after that. I have a blog post on how you can train generative adversarial networks on Azure ML to produce paintings. I have the post on how you can do processing COVID papers on Azure ML to extract some meaning from that. And finally, how you can train question answering model on COVID papers dataset using Azure ML.